Okay, so we are back. I baked the board for a couple of hours over the last day or two. Put it in for another half hour this morning just to make sure everything was fully dried. And now, again, we are back to problem 12 right here on the edge of the BGA with those two balls that didn't get fully reflowed. So what I'm planning on trying here, which I have done in the past, I don't know, it's been years since I've had a major reflow defect, but last time I did have a similar problem, I just got a little bit of flux and squirted it under the area, and just so that we can see also, this is number 12, I'm just going to quickly power it up, and we can see right now 12 is not lighting up, and even if let's just try like power cycle the board and try pushing down in that area or something and just see how much contact we get. Yeah, that's still not enough. Okay, so I'm going to try just squirting a bit of flux under there and hitting it with the hot air. And with any luck, we can get the flux to kind of wick under there and melt the balls. And we should get a good contact. We don't have to melt the whole BGA, we just want to get this one area. And we're going to see what happens. So, 1 second. All right. So hot air should be warmed up now. And I'm just going to go, actually, there's a test point right here. I think I'm going to tin that, not because I need to, but because seeing that melt will give me a better idea of the board temperature. And if I see that melt, I know I'm at least going to be close to reflow temperature on surrounding stuff. Because they don't actually have good visibility in on the edge to know whether the BGA itself has hit reflow. So I'm going to have to kind of guess. What I've usually done in the past is I've put the whole board in the oven if I've had to do a reflow fix on a bad joint. But these PMOD connectors here specifically are not reflowable. I believe everything else on here is. Yeah, so I should remove power. I forgot to take that off. Anyway, so yeah, I'm just going to go hit this area with the hot air and we're going to see what happens. So we should see is pretty quickly. Actually, I gotta put the flux on at a slightly different position because I'm blowing it that way. So I think I actually want to get some flux on this side to make sure that it'll wick under to the balls in question. And again, we don't necessarily care about the entire array. We're just trying to melt this one corner. Alright, so that's the test point melting. And we'll just kind of keep heating the whole area and look and see when like some of the surrounding components start looking a little bit hot. So I'm eyeing like R16, for example, is there we go, you can see it better now. R16 there, for example, I want to see when that looks like it's melted. That'll be another good example that another good indication that I've probably got everything hot enough. I think I might actually be good now. I'm going to take the heat off and got to jiggle the microscope again to get it up a little bit higher. See if I can get line of sight down to those balls. I don't know if I quite got them. They still look a little different, like they didn't fully make contact. So, all right, I'll try hitting it a little longer, and maybe from a slightly lower angle as well. For the new viewers, what we are looking at is, again, the two bolts on the edge of the BGA that did not make good contact during reflow. It's the second and third from the right side in this view. So I hit it with hot air, and we're going to see if that worked. Actually, before we do anything else, let's just let this let it cool off just a touch and see what happens. Okay, that was actually enough. So I thought I was going to have to cook it a little longer, but look at that. Number 12 lit up. So just that one little blast of hot air was enough. I wasn't actually sure from the visual inspection if we had gotten them to melt, but yeah, 12 is good. All right, so now we've got 14, 15, 16, plus there's the one solder mask challenge. So let's begin. Just get the microscope back in position. I think what I might actually do is the solder mask challenge next, or sorry, not solder mask, silkscreen, just because it's something I've never done before, and I wanted to see how it would turn out. So let's clean some of this flux off of here, just to get the area nice and clean. And so this is challenge SM-1 or SM-2, I believe it's SM-1, is just to label the JTAG connector JTAG. And obviously there's a zillion different ways you can do it. You can do it with UV solder mask, silkscreen material. You can do it with a stick-on label. And so I have something that I've never used before that I would like to try, which is it's actually a metal stamping set. Let me go to the bench camera here. So it is a metal stamp set here, and my hope is that, if I can get this open, the lid fits quite snugly. So my hope is that if I take, like, let's just say the J, for example, for JTAG, if I take this stamp, I don't know if it's going to focus, but it really wants to focus on my hand. Let's try that. All right, well, anyway, you might be able to see the J there. Anyway, so my hope is that if I can get some UV cured white ink onto the end of the stamp, I might actually be able to put lettering onto the board and then cure it. So first step before I can do any of that is I need to get the white ink into a smaller syringe for dispensing. When I repackaged the blue and the red for the other day, I did not do the white. I forgot I was going to need it. So let's go hop over to the hood and do that now. It's also getting a little chilly in here, so I'm going to put my lab coat on anyway. Okay, so we want the white solder mask ink, which is here. And a syringe to package it up into, and a lure coupler, which I'm running low on, as well as a cap, and let's do like a 20 gauge dispensing needle. So one of the open questions I have is, how am I going to get the ink onto the stencil, or onto the stamp, because these stamps, again, are meant for imprinting metal. They're not, they're metal, they're not rubber. And I don't have any kind of like a stamp pad or something designed for a hard metal surface. So it's going to be a little bit of an adventure, and one of the reasons I put this problem on here is just to give me a excuse to go try it out. And also the UV ink is nice because if you get it wrong, you can just get some solvent and wipe it off, and you get as many tries as you want before you cure it. So we're gonna see how this turns out. And same deal as before, just kind of shove it up into the syringe a bit. That should be more than I'm going to need. And get the coupler out. Try not get any on my hands, even though I did. And that's garbage. And let's go get some new gloves and clean up the white goop everywhere. IPA takes this off pretty well, at least, so there's that. So my thought is if I get like maybe a slightly compliant surface, like one of those wood stirring sticks, and smear a bit of the ink onto it in a thin layer, I should be able to get it onto the stamp. But this is very much a experiment and I don't know how well it'll work, so. All right, we're done there. Now let's go label the syringe. This is white solder mask. White UV solder mask, and print the label. Alright, so back to the bench camera again. So I've got the tube of the ink. I've got a large needle just for dispensing it. I'm not going to try and actually make any kind of a pattern with a, what is that, a 20 gauge. And we have the board. Let's position it. Actually, yeah, it's probably fine the way it was. I don't think I'm going to be able to use the microscope because the stencils are the stamps are fairly long, and I'm going to have to come down vertically. So I'm going to have to just do this without magnification. And I guess one of the other questions is going to be with the size of these stencils. How close can I get? Actually, I'm going to leave this on just so I get some light. So, yeah, I can get decently close to the connector, so I'm probably going to want to label it like up there. So that is a consideration, is the size of these stencils. I can't get less than like maybe 2-3 millimeters away from a tall object. Obviously, if I was labeling a blank board, that wouldn't be a concern. Okay, so I guess now I just have to figure out how I'm going to get the solder mask ink onto the stamp and off when I'm done with it. Cleaning shouldn't be a problem. So yeah, I think I'm going to try that little wood stick and see how well that works. And if it doesn't, then switch to something else. I might grab some swabs and Kim wipes and a few other assortments to see what actually gives the best results. So let's take 2 of the little wooden sticks and one of those plastic cups. And between these, hopefully we can find something that will work. All right, so let's keep that in view. All right, yeah, we're gonna have to. Is the other stick vise gonna be big enough for this board? Let's see. I don't like having that rod sticking out on small boards, so. Yep, we are just barely within the size range for the shrunken stick vise. So we're gonna switch to that. Okay, so I still have this annoying USB cable in the way, just gonna have to live with that. So we got the white solder mask ink, and I'm gonna keep that tip on there and just squirt a bit out into here. Don't want a lot. I suspect this is very much a less is more situation, but we'll see. And now try and get this little wooden stick and just spread it out. The idea is to create a really thin layer. I want to have good coverage over the stencil, or I keep saying stencil. I want to have good coverage over the stamp surface, but I don't want it to be on like the sides of the stamp or anything. So let's try doing that, and this plastic cup is a little bit soft, so we should have a little bit of compliance here. And yeah, we're actually trying to do silkscreen touch-up here. All right, I think that was too much. So let me actually try a swab and see if I can get even less on. Again, this is going to be the hard part, is I want to not leave a big mess. I want the letters to be clear and well-defined. So let's try putting just a tiny bit on the, I want the side of the swab, really. This is one of those things where, like, the IPC rework guides and stuff, they talk about, you know, using a stamp, but they give no details on what sort of stamp and how you get the ink onto it, and all the important things you would need to actually be able to do the work. All right, so let's try that and just press it against the board and see if I can get a nice J. Nope. All right, it printed nothing. So let's try actually pressing it in like that. That might be too much, but let's see if we can get a letter now. That is very much not a J. All right. I mean, this is about what I figured was going to happen, and I wanted to experiment a little bit. So, and yes, trying to do it with a brush is very much a possibility. I would actually probably use one of those little wires, but I had the stencil set, or I had the stamp set, and I wanted to at least make an attempt. So I don't think a brush would work well. I think actually doing it like pencil style with the wire might be a better choice, but the intent of the stamps was to get nice smooth lettering. But yeah, I think rubber stamps probably would give better results. The problem is I don't have any millimeter to sub-millimeter rubber stamps, and last time I looked for them, I was unable to find any. I only found metal ones. So I'm not actually sure how the professionals do this. I'm legitimately curious. So let's switch back to here and grab one of those little metal pins and see if I can manage to make anything resembling a letter by hand drawing with that. The last time I tried this, I didn't get great results either, and so I would like to get better, because, yeah, occasionally you do have to touch up markings. That's actually working better than I thought it would. And TPU is a possibility. However, I don't know if it would get the resolution. Custom printing TPU is definitely something to think about. I do have a friend in the area with a printer. I should ask her what the smallest feature size, if I wanted to do like, a single extrusion line wide stamp out of TPU, how small it would have to be, or how big. Like, is this, I'm aiming for like, roughly millimeter line height or so. Is that going to be feasible? But honestly, doing this with the little wire on the handle is going better than I expected. So, just putting tiny little droplets and like almost inkjet printing at one drop at a time. I mean, that's not terrible. I think I actually used a little too much ink on that spot. But that's the other thing, is it's not like there's only, I'm never going to try this again and there's only one way to do it. This is very much an experiment, and so, I would like to try printing a stamp and seeing if I can get adequate results. Because certainly if you had more than one board to rework, having a stamp would make it go a lot faster. And yes, definitely the dots seem to work better, but again, I'm learning here too, so I've never done this before. So let's go cure this. And yeah, 0.25 millimeter nozzle would still make for pretty large font compared to some of this stuff. Although, I mean, actually, those lines might be on the order of 0.25. So yeah, just for practice's sake, I think I might try and do a second one and just do pixel printing the whole time and see how that works. And trying to do any kind of like direct write imaging, yeah, it's possible. I suspect it would come with a whole other set of challenges trying to get good results. I would be much more inclined to either stamp or hand apply. All right, that blob was a little bigger. And yeah, this whole stream, like, this is not me showing off perfected world-class rework skills. This is me pushing my own limits and seeing how far I can go. And you know, there are things on this board that I put here that I've never done before on purpose. So yeah, it does look like painting is not the way to go, but also just control of the volume of fluid seems really important. Like, it's very easy to get, I don't even know how many picoliters are on the end of this stick, but like right now it looks like my line width is actually wider than when I was painting, just because I think my drops might be a little bit larger. And yeah, this particular solder mask seems to not be super sensitive to visible wavelengths. I have some other glues that I work with that over just a minute or so, maybe even 30 seconds of exposure to the microscope illuminator will start to cure the surface. This stuff doesn't seem to be like that. It seems to be a lot less sensitive. This is, I think, too much. Honestly, I think the first one looked better. Using the needle to ink the stamp head, that's not a terrible idea. I will try that after I cure this round. But I actually, you know, I don't think that'll work, because I think the problem I actually had was with release of getting the ink off of the head onto the board. Yeah, because let's actually try this. So, let's see. Okay. Rather than using that, I think I'm actually going to try one more thing. I'm going to just smear a bit of the ink onto this wooden toothpick. And then stamp into the toothpick to get ink on the stamp. It looks like it's reasonably well inked. Yeah, no, the transfer to the board was basically non-existent. It just made a mess. So yeah, I don't think these individual letter stamps are going to be a good choice for this. I think they may have use for other things, and I think TPU stamps might have potential, but I think this idea of applying the ink with the metal stamps is just not going to work. But, I mean, I had to try it, so now I've got stamps for other things, and I know what doesn't work. Anyway, all right, so that was challenge number 12, was the BGA reflow, and then SM-1, I think, was the silkscreen touch-up. So let me go clean up the solder mask goop here, and move on over to the next challenge. All right, that's it for sharps, and all of this is just regular garbage. Oh, I gotta put the mask away. Let's do that. And yes, the board is clean. So there is not a specific flag so much as just it's the idea of it being challenge based with defined point values is kind of where the name came from, and obviously from an InfoSec background. Okay, so that was SM-1 that we just did, and let's just verify. Yes, that is SM-1. And now we are up to, we got challenges up to 13. So now we've got 14. I'm going to save for last. That is the backside mill under the BGA. Then we have 16 and 15. So let's do 15 first. That's an easy one. It's just late in the sequence because of when I added it, when I realized I wanted to have an easy challenge for component edition. So 15 is a missing pull-up on a open drain signal, and that is, I think it's on the back side. Let's see if I can find it. Okay, yeah, here we go. Challenge 15. So that is right here. We've got this signal here, and it is missing a pull up. Let's just verify. Challenge 15, yes, it's a pull up. So we need a 10K from here to 3.3, which is conveniently available there, or we can get it from any of a bunch of other places. So let's go plan this out. I lost track of where I was. Okay, so we have challenge 15, let's go this way. And so those are 0402s in that area. So if we have an 0402 coming off of here, kind of like that way, it won't quite contact. So one of the things I want to think about is, because I'm going to be doing a bunch of other milling and similar operations on the surrounding areas here. Just realized I'm not on the microscope camera view here. So this is the trace we want to connect to, and these guys here are 3.3, so we can pretty easily connect from here to there. I just want to try and make the connection a little bit more robust because, like I mentioned, I am going to be doing some more milling in the area, and I don't want to crack a fragile connection. So let me go grab some 10K resistors and a few other things, and I think I might try, just for practice, I might try and actually add a footprint like I did with the lifted pad rework, and see if I can get, what's above the field of view, it's just a via to a pin on the microcontroller. But for the purposes of the challenge, we want to hook up a pull-up near the end. Again, there are a few other possibilities. We could go a little bit further. We can see here on the CAD view of this way. You know, I could try and do it this way, but fundamentally, we've got this whole area. There's plenty of space to do it. And yes, so just bridging across there is doable. It's slightly too large, so it would have to have some extension traces, at least for like an 0402, which is most of what I've got here. Again, my big concern is I don't want the part to fall off as I'm doing other surrounding stuff, and that little surface mount trace for channel 15 for challenge 15 is not huge. So I'm going to try and see if I can do something a little bit more stable and professional. So let me go warm up the glue again. And I'm going to try just adding some new surface mount pads here. So we got the frame kit here, and probably a 22 gauge for the glue. And then I need a 10K, not an 0201, not an 01005. I need a 10K 402. So I can put the rest back in the bin. And we got 10K 402 here. And yeah, so there's a couple of different ways we can do this. One possibility would be to put the part down, like straddling the reset line, put a little dab of glue there to hold it in place, and then secure it to either side. That is a possibility. I'm going to try, just for practice's sake, putting down some pads so I can actually have surface mount lands for it to land on. And we're going to see how that turns out. And see how small do I want to go. Actually, I've got another of these circuit frame kits that might be a better size. Let me try that one. And again, the main thing is I want to avoid a situation in which it's attached on one side and not the other, and it'll come loose later. So that's really the only concern. Is again, like, plenty of things will work okay. I'm trying to make this durable and long lasting. All right, so I got a couple of ones. These ones still have the, I have a bunch of the other circuit frame kits from Circuit Medic that have the dry film adhesive in them, which I don't really like, but they may have the shapes that I'm looking for, and I may just have to scrape off the adhesive to get better results, because like this one here looks like it might actually be more appropriate for the footprint I'm trying to do. So let's leave this one out. And this one is a bunch of, so I think these actually might be better. Let's leave this one out too. I think this might actually be the best one. This one is marked as expires in 2016, so the adhesive is probably bad, but that's fine because I wasn't planning on using that anyway. I was going to scrape it off. All right. And yeah, 603 and 805 absolutely would work. Again, there's a lot of different ways to do this. Okay, so let's grab that 10K resistor and let's see which of these pads fits it best. And yes, this is my home lab. It's well equipped. I've been building it for years. I use it for day job stuff as well, so I can justify spending a fair bit of cash on it since it's also for work. So these look about right, give or take a bit, pad sized. And so the adhesive that these, let's just get this resistor out of the way here. The adhesive that these things are designed to have is, it's a dry film that is supposed to be thermally cured. My experience is it doesn't really cure that well on any of my test setups, and it ends up just kind of getting goopy. And so I'm going to try and see if I can get the adhesive off. So I'm going to cut a pair of these pads. And then cut the adhesive as well. And if I don't get good results with this, I can always switch back to the ones with no adhesive, which is what I'm using going forward. It's just I want to use up the old ones, and if I can get the adhesive off of them, or if I can make it cure, that may be good enough. This is some kind of like B-staged epoxy or something that is supposed to be heat and pressure cured, and yeah, it never worked for me. Alright, so that's one pad, and then here's the second one. And again, there is still a lot of adhesive on here that's going to have to come off, so I'm going to see how much of that I can trim and if it's even worth doing. So the intention here is that you would just take this and you'd press it down with basically a soldering iron against the board, and the heat will cure this glue. But yeah, what I found is it usually just kind of turns tacky and it doesn't actually cure fully. So I'm going to try and see how much of it I can just scrape off. We don't necessarily have to get all of it, but at least thin it enough that I can attach other stuff to it. And let's get the other tweezers. Oh, so you were suggesting not a printed TPU stamp. Can you buy TPU stamps that are really small? Do you have a recommended source for them? Last time I looked into acquiring stamps, everything I found was like multiple, like I think 1/8 inch or something line height, which is like 3 millimeters was the small that I saw for sale from like art supply stores and stuff. If it is possible to get smaller stamps, great. Please let me know where. So no, I wasn't going to use supplementary underfill. My plan was to try and get the existing adhesive off and then use the red adhesive on it. Okay. Oh, interesting. So print a mold and then push TPU into it. It's an idea. If I was going to do that rather than thermally molding, I'd be more inclined to try like casting silicone or something, but just because I've got the equipment to do that. Or at least I did. I don't know if it's still good. It's been a couple of years since I've used it last. yeah, this is a pain. I mean, it is always possible I can try and get this adhesive to cure. Let's go. Okay, so I've got this here. And then this is the one that I'm trying to put on the other side of it. So here. Oh, come on, where did it go? This is always the hardest part, is you spend a bunch of time working on something and then one slip of the tweezers and you fling it and you never find it again. I've had that happen more than once, and I think it may have happened again. Is it stuck to my hand? Where is it? I see the resistor. I see the other pad. Alright, yeah, I'm gonna give up on this scraping. Getting the adhesive off of these existing pads is just too much work. I am instead going to switch to what I probably should have been doing all along, which is just to cut the pads out of the non-adhesive backed stuff like I used for the, I forget which channels it was, the one with the flash chip that was lifted. 6 and 7, I think. So let's go back to here and let's pick out a pad size to put on here. So we got the 0402 resistor, and we've got those pads are overkill. Those are actually not half bad if I cut them down to size. Yeah, I'll do those, and I'll just cut one of them in half, and that should actually be pretty good. Okay, so I think that'll work. So we're going to want to leave a little bit of track coming off it on both sides. So about like that. And about like that. And yes, these are different size tracks. I can live with that. All right, perfect. So this is just bare copper with no adhesive backing. And I dropped it, and I found it, and I dropped it again. This is the hardest part sometimes. Oh, there it is. Just handling something this thin is really difficult. If you hold it by the edge, it's okay. Okay, so we got it roughly in position. Now I can put the unused pads back. And so the plan is going to be start with, let's just do it like that. And I just realized I'm not on the close-up camera. I will switch as soon as I do this. Cut. This is regular tweezers, there's no vacuum. Okay, so we want to do the larger track like that. Figure out how long it's going to be. Connect it about like that. So I need to cut a bunch of length off on both sides. I'm just going to move this to over here, so I've got a little bit more room to work and I'm not cutting directly over traces. So cut that and then cut the pad down. Perfect. And then lift off the two pieces that I cut. Make sure we don't lose those. Alright, so I think I'm at the point that I'm ready to go get just a tiny bit of glue on there to secure the part. Or to secure the pad. So get the needle out and that's way too much. More like that. And then I'm just going to try and bend that up a little bit and put that in position. So that should hold that pad where I want it. And then I can add the, I can solder it after it's in place. I'm going to add just a tiny bit more glue on the sides to make sure it doesn't go anywhere. A little more actually. And so I've got the pad in there, and I'm just trying to get a little bit more attachment around the edges and just make a little bit of a lip and kind of create the equivalent of like a solder mask defined pad here, so I know it's not going to go anywhere. And then I'm going to pick up the other pad and just move it safely away for a second. And the same for the resistor. So now I've got this one pad right where I want it. And I'm going to try hitting it with hot air to cure it. And see if I can get it to stay in position. Last time I tried hot air curing, it didn't go super great. I'm just going to try and hold this here, and the finish will get less shiny and the surface will look a little duller as it solidifies. That's usually how I tell, is when the shininess goes away. I feel like that might have done it. It says it cures in only a couple of seconds as the temperature goes up, so. That is definitely not cured, okay? I need a little longer. Like a 10-minute oven cure I know is gonna work, it's just I don't really feel like waiting 10 minutes, so I'm trying to get it to stay put at least enough between now and then. I don't know if the hot air cure might be too aggressive. All right, let's see how that did it. All right, yeah, that looks to be secured. Okay, so now I need to do the other leg of the part. So let's go get the component so I can fit check against the pads. And so ideally what we want is for the component to sit like that and the other pad to sit like that. And I'm actually going to position the pad like that. Okay, so I definitely need to cut a lot of length off of the pad, and the trace I can probably leave as is, but I'm going to shorten the pad until it's about square, I think. Alright, so that's that. And now plan is going to be, we're going to drop this down. Let's actually aim to be like right on top of the existing trace. So if I do like that, and then like that, that should solder perfectly. So I'm going to aim to put a little bit of adhesive down here, leave that section not adhered, so that then I can go scrape off the mask there after everything's done and attach it. Okay. So, adhesive here. That is definitely more than I need. And lift the pad up. And flop it down. And positioning. And now a little bit more over the left side to secure it. It's actually good if I get a little bit over the edge of the pad here. Let's just move this down so you can see better. Alright, that should be good. So now, same deal as before, hot air cure this, and then we can go make the electrical connections. I'm going to say hopefully that's good. Not perfect, but I think it's at least secured enough it's not going to go anywhere. And the glue is Loctite 3609. It's a one-part thermally cured epoxy. It's one of the few things I have around that will survive soldering temperatures, so I use it a lot for this kind of stuff. If I'm not going to be soldering directly on top of it. Yes, it is the same glue they use for that. It's not magic, it's just exotic and expensive. Alright, so that's tinned, and now we're going to try to actually put the resistor on, and then just have to make the electrical connections on either side. So, resistor is over here. And I'm going to swap things around so I can have the iron come in from the other side. Alright, that's that. And then solder on the other side, and now I just got to make these pads electrically connect to the rest of the system. And yeah, I don't know why it's so expensive, other than it's just a small volume thing, so yeah, I use it enough professionally I can justify the cost. I'm sure there are other options if you don't care as much about reliability and such, but this is the industry standard for a reason, so. Alright, so we got a good connection there, I think. And now I'm just going to clean up a little bit and scrape some of the scrape some of the solder mask off so I can get the connection on the other side, and should be good to go. Alright, so that's done. And now a scraper. The component is not really matched to the gap. So that is the whole point, is if the component is not super well size matched, then you do have to do stuff like this. If the component was a little bit smaller, or if the component was a little bit larger, then it would have been easy to just stick it on, glue it, and then, yeah, you still have to worry about how you're going to attach it, though. And also, a lot of it questions as to, a lot of it depends on, you know, really what you're trying to accomplish and how close you're trying to get to the original board configuration, and, you know, how much deviation you're willing to tolerate. So the closer you want it to a factory state, the more important it is to do things like actually replacing pads rather than just willy-nilly dangling bodge wires everywhere. This is definitely going to be a bit more durable. Alright, so I think that should be good. And yeah, if I had 0805 10Ks, but I don't. I've only got 0402s and smaller, so. Sometimes it comes down to what tools you have on hand for the job, and they may not be objectively the best if you had everything. And yeah, you absolutely can secure wires after you've put them on. Again, there's a lot of different ways to do this. Alright, and I just gotta get a little more flux on there. Soldering to these bare traces is always tricky. And yeah, 0402 is my default. I go bigger for power stuff if I need to. I go smaller if I have space constraints. But if I have no reason to choose a different size, 0402 is going to be the default. I still don't like that. Well, it's definitely not making good contact on that end. What if... Let's just... Alright, well, I think that's probably good. I don't like having that little pointy bit where it's not making contact on the edge, but it seems to be making contact everywhere else. So I'm going to go clean the flux off and then take a quick electrical measurement and see if it's good. And yeah, actually, just, 2 days ago off camera, I had a board with a USB port that was legitimately ripped off. It had been sitting in my parts bin for probably a year waiting for me to get around to it. And yeah, I will show the issue in a second after I get some of the flux off so you can see better. Right down there, that you can see the solder is wetting to the pad, and then there's this kind of spike coming up off the side of it. So that's not great. I think we'll be okay with the amount of adhesion elsewhere and the contacts that I've got elsewhere. I don't think that one little bit not making good contact is going to be a problem. All right, so that was challenge 15, I think it was. So let's electrical test. All right, yeah, 15 is passing. All right, so now I can turn off the noisy stuff and hear myself think again. And probably put away the glue. I don't think we're gonna need the glue. I don't think we're gonna need the pads anymore. So we've now done the last solder mask, or the silkscreen challenge. We've done the missing pull-up. All that remains, I think, are 2 interlayer challenges. How do you fix it? Making the solder flow properly, basically. It can be a combination of thermals and oxidation and a bunch of other things. And so I think what's happening here is just the solder is not cleanly wetting the very edge of the pad where I scraped off the solder mask, and I guess there's probably still some solder mask residue on there. And sometimes in this kind of rework case, it can be unavoidable, but I just don't like it. I think there's enough elsewhere before that spike that it's making good contact that it's fine, but you know, an IPC inspector would yell at you for that. Okay, so let's go put away some of this stuff, and we're down to 2 interlayer rework problems. I have a rough idea of the order I want to do them in. They are both going to be challenging. Probably will not get both done today. I'm going to probably do one and then likely be out of time, but we'll see what happens. So, just cleaning up here a little bit, getting some of my other tools put away. What I think I'm going to start with is challenge number 16. I'm going to go to the CAD view real quick. So, challenge number 16, which is, I forgot to clean these tweezers too. Always want to get all the flux residue off of them. The last thing you want is things sticking to your tweezers when you're trying to do stuff. Okay, so that's that. And we're on challenge number 16, which is pin R16 of the microcontroller was strapped wrong. So let's see, challenge 16, there should be a marker on it. Okay, here we go. So it's on the edge of the array. We're on the edge of the array, and so this via here that the arrow is pointing to is connected to ground, and it should have connected to the 3.3 ball route. So we've got a couple of components around it, but nothing too bad. Going over to the layout here on the CAD view. So here we're looking at the back layer, and we're flipped. So we've got this one capacitor here. Then if we go up, next layer is 3.3, which is where it should connect. Next layer is ground. So we need to go break this ground connection here and leave the via barrel intact. So it's going to be kind of similar to the other situation. We had the via shorted to the internal plane earlier. The difference is that in this case, we're coming up from the underside of the BGA. We don't have access to both sides of the via. So the front side here, this is layer 1. Layer 2 is what we need to break. So we need to go down all the way through the core of the board and hit layer 2 and then reconnect it back up to layer 3. So what I'm thinking is going to make sense here is to come in from, let's look at angles here. So mill in from, I guess it's going to be the south as seen from here, and try and hit the via, leave the capacitor. Actually, no, I think I might take the capacitor off just so I don't damage it, and then we can put it back on afterwards. It'll give me a little bit more visibility, a little bit more space to work with. So I'm going to turn the soldering stuff back on real quick. So yeah, I'm going to take C9 off, and then once C9 is out of the way, so that's C9 here, C9 is going to come off. Yeah, handheld vacuum systems, I've played with a little bit, not a huge fan for what I'm doing. Anyway, so yeah, C16, or C9 is going to come off, and then we're going to mill down, go from layer 4, punch through layer 4, there's nothing there, go to layer 3, expose part of layer 3 that we're going to need to later connect to, then go down through that to layer 2, break the layer 2 connection, and then reconnect the via. So I think that's going to be the plan, and all right, so this is here. Alright, got the part off. That was easy enough. And I'm gonna probably, yeah, I'll deflux the pads and clean everything up nicely while I'm here, just so I don't have to do that later. All right, so the pad is cleared off now. I'm gonna save that capacitor. There's nothing wrong with it. We can put it back on when we're done. Braid away, iron off. And yeah, I have a hand-operated, not a continuous suction, just like a little squeeze bulb type thing. I use it for placing big BGAs and stuff. I don't use it much on small components. Yeah, I'm sure there are plenty of ways to do it. The one thing it might actually be useful for is handling the really thin repair traces. But I feel like any kind of a suction system would probably just get gummed up by flux. And yes, I do not like the squeeze bulb things, but it's what I've got now, and I can't use tweezers on the really big stuff, so it's what I got. Again, I'm not saying it's the best way, it's just what I've got available to work with. Okay, so we've got here, so we're going to be coming in, milling a stepped cavity from this angle. So I've got visibility coming in through here, aiming for that via, and we want to break the connection from that via to layer 2, and then reconnect it up to layer 3. So over to West Bay long shot. Gonna take a minute to hook everything up. Eighth inch is, I believe, 3.125 millimeters. Okay, so let's see. So we're going to be coming from this side. Board flex is a concern with this, so I'm going to have to go slowly, and I'm not thrilled about the stick out here. So the problem I'm running into is my vise here holds the board by the edge, and with those big connectors on, I am not able to get the clearance that I want. So let's move over here. All right, well now I have the gas needle hitting, so I'm going to fix that separately. Get the mill roughly in position. All right, so now the gas is gonna there are too many things coming around here from different angles. So let's soften that and try to get the gas coming like that, maybe. And then adjust the camera position slightly. To try and get the best focus. All right, I think that's pretty well focused on the board surface where I'm going to be working. And I'm going to crank this just a little to the left because I am trying to create. All right, that's probably about as good as I'm going to get. So now let's just quick check if yeah, okay, I'm not liking that. The board is springing a bit. So I'm going to have to change how I'm fixturing this a little bit. And yeah, I'm going to, let me switch over to here. So I am going to make the microscope be just a little larger, but I'm not going to switch cameras completely because I am going to be shifting around fixturing a little bit still. So let's lift up the mill again out of the way. Yeah, so these big connectors are really the hard part. I may have to actually come in at a bit of an angle. I don't like it. Let's see what happens if we actually do a perpendicular cut. It'll go under C9, which is one of the reasons that I took it out. I was hoping I wasn't going to have to do that, but I might have no choice. So I'm going to totally shift a bunch of this. And then get this coming in, clamp from around the back. And let's fit check this and see if I can get all of the parts that I need to clear while I'm doing this. All right. So that's the mill is going to be coming down from the top here. And then we're going to be working over there, and the gas is there. And now I just have to totally reposition the camera so that you can see again. So this is one of the reasons I took C9 off. So now what I'm looking at doing is potentially taking a cut like from around here, and it is going to go through the edge of C9, and it'll probably cut off like half the pad. There should still be enough there left. I can put it back on, or I can always touch up the pad afterwards. But the plan is going to be do the deep cut here, and then start going shallower as I move out towards here. It is going to have to be about 1.4 millimeters deep to hit layer 2 from the underside. So this is probably about the best angle I can come from, especially, again, the way that the board is being fixtured. So there's still a little bit of a flex there, but less than I had before. I still don't like it. I'm going to have to take light cuts and stuff just because of, again, I don't want the board to be flexing as I'm drilling, because as soon as the board starts flexing, your depth of cut becomes very unpredictable, and that's exactly what we don't want here. All right, yeah, I think that'll probably do. Comments here. Okay, so yeah, so we're coming in from, just gonna put the CAD view up so people can see where we're coming. So we're now gonna be coming in from this way in the CAD view. So I'm gonna start milling and I'm gonna see what happens. I've got enough depth clearance that if I go down to like layer 3 or so and I'm having real bad planarity issues, I can look at refixturing the board or something like that. There's quite a bit of space to go before I hit anything irreparable. So. Gas on, tank on, and we're going to keep on doing like 3 psi is what I was running before, I think. Yep, all right, 3 psi should do good. And suction coming on. Spindle going on. We could probably get away with a smaller hull, but I'm going to err on the side of bigger for now, just because I want to be able to see what I'm doing. Better visibility is always good, and so there is some creep somewhere I need to figure out, because I did not make a Z adjustment and our depth went down by more than I would have liked. Alright, so that is through layer 4. Now we're going to go down a bit and we're going to try to hit layer 3. I'm going to do like, yeah, let's do like 100 micron depth of cut here. Because I know we need to go down a lot. That's a very aggressive cut for what we're doing, but should be okay. Normal machinists here, as you say, a 0.1 millimeter cut is aggressive. They'll think you're crazy. But for what we're doing here, it actually is. Alright, so I'm just going to stop the spindle for a second and turn off the suction just so everyone can hear me a little better. So what we have right here, we are on layer 3. We're just above layer 3, and if you look right back here, I don't know if it shows up on the other camera view, but we are getting very close to, there is another trace I need to not hit. Going over to the layer 3. So now we're up to here. So right here, this is a V-core trace that is connecting a few other things on the board together. So now we're coming from this side where we have to make sure we don't cut through this. It's okay to cut all of this on the layer 3 plane, but we need to not cut through the V-core. So I can see it, I can avoid it, it's not a problem, but just thought I'd call it out. So now next step is I'm going to go down to here. Perfect. Let's go down another like 5 microns or so. I've got some backlash going on here. Get this there. I think I want to go just a touch further. I think I'm just barely scraping the copper layers here. Okay, that looks like we're actually starting to go into the copper layer. Yep, alright, perfect. So we're in the copper layer. This is now layer 3 that we're exposing and not puncturing. And I'm just going to mill all the way down to that across the hull cavity. And then we're now going to start going down towards layer 2, leaving a little bit of that layer 3 lip intact. So I'm going to go down, let's say 50 microns. So Now we should be through the ground plane. Again, this is a very big haul. I'm just trying to get good visibility because I know there's nothing in this area that I care a whole lot about. And I'm going to leave some of that layer 3 intact because I want to be able to solder to that power plane later. So now what we've got to do is get this via down far enough to break the connection to the ground plane on layer 2. We don't have to be super concerned about depth because if we punch through the ground plane rather than exactly going flush with it, it's fine. We want to break that connection. You can see now the cavity is starting to get a little bit stepped. I want to maintain that visibility down into the cavity from my perspective. And down another 50 microns. It's actually still a fairly aggressive cut. You can see the end mill is deflecting a little bit to one side when I do that, so 50 might actually be too much. At least for fine milling. The mill is just starting to bite in a little bit. So now we're going to go down a little more. Let's do like 20 microns this time so you get less of a deflection. Still feels like we're getting just a little bit of deflection going up that way. So now this is where we're starting to get to be into serious high aspect ratio territory here. And you have to pay careful attention to the angle of the mill. So like right now, as I start going down here, I can no longer see the tip of the end mill. It's now going down into the cavity, and I can't see it. So I probably don't need to be removing that material all the way that far back. But at the same time, I do want to make sure I'm removing anything that is going to block my view of the via as I start getting down there, because I do need to be able to see the via. So I might actually step the cavity again and start machining a smaller hole. 2.5, or 0.25, sorry. Go light here a little bit. Okay, yeah, I can definitely see the end mill is really trying to hug to the left whenever I go on that edge, so I gotta keep doing all my milling counterclockwise. And 50. Another 50. Just stopping for a quick inspection pass here to see where things are. I am beginning to actually lose sight of the edge of the via, which is going to make this a little bit challenging. I may actually want to advance the cut a little bit forward just so I can see the bottom copper layer right here. Let's actually see. All right, so we are now, if we go down to, let's just say the edge here. So that is just barely touching the surface, roughly. So that is about, all right, so that's going to go 0.7. So that's 100, 200, 300, 400, 5, 6, 7. So we've gone down about 700 microns. Yeah, I'm going to have to go quite a bit further. I want to say we have to go about 1200 to hit that copper layer. So yeah, I may actually want to make the cavity a little longer or something, or even just take out a little bit more of that power plane, because I need that visibility. I cannot see the bottom of the hull from where I'm working. And this is one of the challenges with these high aspect ratio edits. The other thing I can try doing actually is I can try moving my microscope up a little bit and adjusting the angle a little further. That might buy me just a little bit more. All right, so I'm moving the microscope up and I'm tilting it more sharply down. And now I'm hitting there. So that is one of the challenges with these high aspect ratio mills, is just trying to see what you're doing. Okay, yeah, so I think I'm good if I move the microscope to a steeper angle. I can now see most of the way to, yeah, I can see most of it now. Just gonna check the chat before I get back to milling again. All right, suction back on. Of course, soldering to this V is going to be a whole other can of worms once I finished the machining. But right now I'm just trying to get down to that layer. Yeah, I think I'm going to have to cut that lip there. So let's actually do that now. So I'm just going to go like this. I don't care that much about depth. I'm just trying to get a little bit more width here. Alright, and now I've got so much more visibility going down into that hull. So, depending on exactly how sharp of an angle down you can get your microscope, that is going to affect the highest aspect ratio that you can at least usefully work with and be able to see what you're doing. also watching because the end mill gets wider towards the top bit, and I want to not damage the, I want to not bash the end mill into the sides of the hull. So I may have to make the hull a little less wide as I get further down. Alright, and I am blind again. I cannot see the bottom of the hull anymore. Oops. Really? I banged into the hand wheel and snapped the end mill. Alright, well, let's go fix that. That was not even me not looking. That was literally me reaching for the focus in the microscope and hitting the hand wheel instead. Well, that was dumb. And I don't know exactly where the mill went, so I'm just going to suction that area and hope I get the broken cutter out of it. Okay, now where did I put the replacements? There's a 250. Just when I was hoping I would not break this one. I'm also just going to check my gas consumption. Okay, I'm good there. So I'm actually going to just turn the gas off for a minute while I'm repositioning things. Okay. So I'm trying to reposition the microscope in order to get a view into the bottom of the hull that does not collide with the mill body and does not max my focus. So let's move this back a little bit. Alright, so I can see now. The question is, when I move the mill into position, is it going to hit the microscope? Yeah, okay, so the mill is hitting the microscope from this angle. So I need to go lower. So let's leave that like that. Yeah, aspect ratio is a big challenge doing this sort of work. Just because I need to be able to see when I've hit the target. Alright, I think I may have an angle that'll work. I can see the bottom again. Don't know how much deeper I can go, but I can see the bottom. And yeah, trying to get the camera in at that angle is going to be near impossible. These end mills are 2 flute. I don't think they make 4s this small. Okay, suction is on, and let's keep the gas back on as well. Go up to 3 psi again. All right, I think I'm hitting it. All right, I think I've hit the wire. Let's get this mill way out of the way so I don't break another one. Gas off. All right. Yep. It looks to me like, going over here, looks to me like that was layer 2 and we just blew through it. So that was right where we wanted to stop. And now looking from the top, you can probably see more clearly that V-core trace that we need to not break, which is intact. Okay, so it looks to me like we are good. I am going to go and take a quick probe measurement there, if I can get a probe down into that hole, which will be an adventure in itself. And we're going to go see if that via is shorted to ground still, or if we broke the connection, just to make sure before we do anything else. And let's see, C9, which of those pads? Okay, so the pad on C9 towards the edge of the BGA. So that is the, I guess it's going to be the right one in this view, is ground. All right, I'm not going to be able to do this in the vise. I have to tilt the board for sure. All right, let's try and get this angle to work. Soldering this is also going to be an adventure, but one step at a time. All right, so first things first, let's make sure we've got a connection here. Okay, good, that's what we wanted. All right, let's get the microscope up again. Up. All right. Okay, so we're in the hall. And we're not shorted. Okay. Now I just gotta get it out. Okay. So we just got to get a connection from that via all the way up to that power plane. Well, can't be too bad, can it? Famous last words. So what I'm planning for this is similar to what last time I had a high aspect ratio edit like this. Is try and get an iron, which is turned off just to show you. Let's find it again. Where are we? So try and get an iron down to that, and then just press a piece of that 100 micron wire against it, get a connection, and then we should be able to have it go up, out, solder to that plane. And then once we've soldered to the plane, then we should be able to start reconnecting things. And then on the way out, to get everything restored to original condition, we're going to need to fill that hole with epoxy of some sort. And then probably I would honestly want to put another piece of pad on top of there to get C9 fully reassembled. But before we do that, let's just grab a swab and get some of this FR4 dust off the surface. Alright, so I got a scrap of that fine pitch wire here that I think should be big enough. Just gonna leave that on the vise so I know where it is. So I think what I'm gonna do now is try and get a tinning on that via, because it's gonna be hard to get. There's no way I'm gonna be able to manipulate solder. And actually, that's cool. If we look right here, we can actually see the dog bone trace coming off. Let me try and get the angle just right. With the IPA in the hull, the FR4 is transparent enough you can see the dog bone trace coming out at about the 5 o'clock position. And then I think we're actually looking through that V at the underside of the BGA, possibly, because I think the via is open. Anyway, we're right where we want to be, and it looks like we've got a good contact, so next is going to be getting some flux down there. I'm not going to be able to use the vise much for this. This is going to have to be entirely handheld at weird angles, because the vise is not going to work at this kind of angle. 1 second. Okay, so we got that. Now we got to get some solder on the end of the iron. I gotta tin that, it's not sticking. I'll just do the tinning paste, that'll work fine. Alright. So let's see if I can make this work. Alright, I think that's good. Alright, there's solder on the pad. So now I gotta get the... I think what actually I might do is I might connect it to the top layer first and then try and go down. That might be better. Although I don't know if I can get a scalpel in there to cut it off when I'm done. So I don't know, it could go either way. Yeah, I'll try coming in from the top. Okay, so we've got the wire in place now, and it's just not attached. So what I might do is I might just get some Kapton tape to secure it to the board surface, just so it doesn't flail too much while I'm working. This is not the final position of the wire at all. I just need it to not move while I'm working. And actually I need more of it. Alright, so we've got the wire, just have to get it bent down, get it into the hull. That's right about where I want it. And now I got to get the iron in here. If this looks like a massive pain in the neck, you are absolutely right, it is. Every time I do this for real, I hate it. And even on practice, it is a really hard time. But that looks like I got a connection there. I got solder in there and going up, and I'm just gonna have to make sure it's not shorted. And then I should be able to just make that connection to that plane on the surface. Let's go get back in the vise again. I think I'm just about done actually on this. So, solder coming in from here, connected on there, and then quick verify that we did not short the 3.3 and ground layers together, because that would be bad. Yep, okay. So just about done with the edit proper. I'm going to cut this excess off of here. Alright, so that is the extra repair wire gone. So we're going to take a second look at what we've got here. And probably just touch up that solder joint one last time, make sure everything is good. Let me actually get a scalpel and just hold that in place while I'm soldering it. It really wants to walk around a little bit. All right, so I think we're good. Iron off, smoke extraction off, and now I'm gonna go clean up some of the flux residue off of everything and see how much better it looks. Before we do any backfilling, obviously gonna have to electrically test, but I wanna get a, and then of course, we are gonna have to put C9 back there and figure out how we're gonna get everything nicely cleaned up there. Right now I'm just trying to remove surface flux residue so I can get a better view. We're probably gonna have to do like a spray clean or something in there because there's no way I can get any kind of a swab down inside that hull. Let me just try and hold the board some angle that's going to give viewers a better look at what's going on. All right, so there we are. This is the via mill down to between layers 1 and 2, and the solder connection from there going up to layer 3. So this is a fully buried edit once we've backfilled. And then we have the untouched connection to V-core. I think we are good to go with a electrical test, and if it passes, then we can start thinking about cleaning up the surroundings and backfilling and putting C9 back on. This was challenge 16, I think it was. Yep. 16 is passing. All right. And that's funny, actually. I see some FR4 debris coming out from the underside. It looks like it came out under the BGA, probably through the via. So I'm going to want to clean some of that off. Anyway, let's go to the hood now. And I'm going to get some of the safe wash, I think, to start and just kind of soak and spray it in that area. I'm going to get some fresh stuff out of the original package because it was starting to turn pretty green before. So I'm going to get a fresh round of that. And also looks like my distilled water on the bench is running low, so I might have to grab another one of those, but I'll deal with that later. All right, gloves and goggles. And there's our container of detergent. And we've got a 10 cc syringe, and we're gonna do a 22 gauge needle for washing, and let's not drop another one. Cleaning tray here. And there's our extra used detergent. Okay, so let's see. I'm gonna want a beaker to put some detergent in while I'm working. That's known clean. That should be more than enough. So you can see how much bluer it is rather than green in the new state, and then it turns yellower over time as it ages. So because I don't have any way of spraying in under there, I'm just going to quickly do a spray wash of the top side to get some debris off from previous stuff and all the machining debris. Get some soaked on the underside everywhere. And now let's just find, okay, so that's our landmark. So now I'm just going to do a high pressure spray with the safe wash in the mill cavity, or as close to it as I can get. It's a little hard to know where I am, but I think I'm just basically pressure washing it now. And I'm just going to dump like 50 mils or so of the detergent in here. Make sure we get out as much flux as we can. And then do a distilled water rinse. and see how clean it looks, or if we have to go back and do another cycle. Alright, that's a decent amount of cleaning. I'm also just going to wipe some of the detergent on right here along the USB connector. There's some visible surface flux that I just don't like, so as long as I've got the board covered in flux remover, might as well clean everything. Alright, so I'm going to go rinse this, and we're going to see how everything looks. And sorry for not switching cameras, but my gloves are rather contaminated right now, and I don't feel like touching the computer. So until I've finished rinsing this off in the sink and taken my gloves off, you're stuck looking at the inside of the fume hood, because that's what I left it on. The realities of being a one-man shop working in a lab is sometimes, yeah, you get stuff in your hands and you can't mess with the cameras. All right, clean hands, and we'll go over to the bench overview. That angle should work fine. And let's grab the dust spray and get as much as I can off of here. Clean the top side. Well, it's still wet, but it's less wet. And I can spray it again to get any remaining residue. Actually, let's give it another good squirt. All right, so back to the area that we were just working on. That looks pretty clean. I think there might be a little bit of flux residue at the very bottom of the cavity, but I don't know if I'm ever going to get that out. I can try, but it's probably not worth it. You know, actually, I may try just doing kind of a flush of it with acetone from the top. Curious how well that'll work. But everything else looks nice and clean. So let me go put the safe wash away. And actually, you know, now that I think about it, I may actually try, yeah. All right, I think I know what I'm going to do. So let's put this away. That goes in the sharps. Did I switch to the hood camera? And yeah, either acetone or IPA. I find IPA usually leaves a bit of residue. Acetone is something I use on small areas when I know it's compatible with the materials I'm working with, which in this particular case, I know what's in this hole. But yeah, I'll try IPA first. So just a quick wipe down here, get any debris off of there. board is out, and quick rinse of the beaker, and I am out of distilled water, so let's go grab another bottle of that. If I can find where, there it is. And yeah, I don't know what kind of silkscreen you're using if acetone takes it off. Silkscreen is normally a epoxy-based ink that is pretty chemical resistant. I would be a lot more worried about melting connectors with it. And so that's why I don't generally use acetone on large areas. I use it on like bare PCB substrate where I know the only thing it's on is solder mask or something like that. Anyway, let's get that out of the way. And hood off over to the main bench. And we got this, and we'll keep the 22 gauge there. So what I'm going to try doing now is just getting some IPA in that hole and just do like a positive pressure spray, but under the microscope, and just kind of flush in and out and recirculate a little bit. So let me get actually a beaker, and let's do like, I don't know, a 10 should be fine. All right, so here is some IPA, and going over to the microscope view here, mount it up in the vise again. Yeah, 10 cc was perhaps a bit excessive of a syringe for this, but it's what I've got. Actually, you know, I'm gonna put the 10 away. I want more feel of what I'm doing. I'm gonna get a 1. It's not like this hole is anywhere close to a cc anyway. We're looking at actually using microliters of solvent here. So yeah, just flushing and sucking. I'm gonna say that's as clean as it's gonna get. Just checking angles here. Okay, yeah, I think that's everything. It looks like I got out whatever was the bottom there. So we are definitely not touching the ground plane, and looks good. All right, let me go clean up the solvents real quick, and we can start looking at backfilling that. And yeah, ethanol is always an option for cleaning things as well. Really, it's a question of what works best in your particular flux. I know acetone takes this off. I use it when I have no alternative. IPA works okay, but yeah, it definitely does not give as good of a clean. So, all right, and where's my solvent waste? I need to do a hazmat run soon. My solvent waste jar is getting pretty full. The disposal is not particularly expensive. It's just a long drive to get to the site, so I always end up putting it off more than I should. Okay, so we are done with the sprayer. Okay. So I'm thinking I might just use that same UV solder mask material and build it up in layers from the bottom of the hull. I could do 3609. I'm not sure which would work better for this, but I feel like probably going UV cure rather than thermal cure for this might be better. I mean, we don't necessarily need to fully fill the hull at this point. The goal here is just going to be to maintain a flat surface and protect it, or not a flat surface, just protect it so that nothing else gets in there and corrodes or shorts or anything like that. So I still have that thing from a couple of days ago, and I don't know if it's still any good. I'm going to grab a little swab and we're going to find out. And if I have to make a fresh batch of the purple solder mask, that's not a big deal. Yes, still looks okay, so we're going to do that and cover this. Make sure we don't leave that power plane exposed. And yeah, I think this batch of solder mask I made is definitely starting to not be happy about how long it's been out on the bench. I was surprised it didn't goop up immediately, but it'll do. Yeah, the viscosity is definitely higher than when it was fresh. So I think maybe either ambient light is starting to cure it, or it is just having like solvents evaporate or something. I'm not actually sure if I'm going to be able to do the bottom of the hull with it like this. Alright, I'm going to cure this and I'm going to make a fresh batch of solder mask, because yeah, this is definitely not good anymore. I got to cure what's on there though. Alright, so new cup and red and blue, and I'll try mixing those a little bit. That is red, and that is blue. And we'll get 20s. Alright, so that was the red, and now we got the blue, and this is a less conspicuous place, so I'm not going to worry as much about an exact color match. I think this is definitely a little bluer than an exact color match, but right now the focus is just on protecting and coating the exposed surfaces. Actually, you know, that's actually a closer color match than the red stuff I had before, I think. Yeah, I think it's a closer color match than the first batch. So now I'm just trying to get some down in the bottom of the hull, and it is proving to be a little challenging. Trying to get the whole milled surface covered and then go down to the bottom. I really want to get that solder joint area covered, just so I don't have anything exposed to vibration or whatever. The problem I'm having is the solder mask is getting. Actually, no. Let me see if the wooden stick is too big to get in the hull or not. Yeah, that's too big. I wish I had like a pokey thing in between the wire and the stick. Would be nice at this point. I'm trying to get as much as I can on the wire. And I want to get the glop on the bottom. I can't get it to flow. There we go, finally. Yeah, I think I'm just fighting surface tension at this point. And now I just have that one little blob down there on the front left, I guess, side. I want to try to get it into. Okay, Come on. I want to get that one little blob. There's one little void there. And the surface tension keeps pulling it back. Alright, I think that's probably... Alright, I think that's probably good. Now I can just give this a couple of hits with the UV to cure it. And then I can solder that capacitor back and just make sure we didn't break anything again. It would be very upsetting if we did, but... Making sure I get good angles on all sides of the hull. All right, so that is our finished rework, and now we should be good to go and put C9 back on. I could be an overachiever and try and put a full-size pad on the other side. I think I'm going to try and go without and see how well it stays, just in the interest of time, because I do have work to get back to, and I want to put a bookend on this edit. So we're going to see how that works, and if it ends up being too fragile, then I can always take it off and put a more permanent pad on. But first I gotta put these solder mask needles away and get off these blue and red gloves before they get on everything. Alright, that glove can come off so I can put these away. Alright, so final electrical check. That is challenge 16 is good. That leaves 14 as the only one left for next stream, whenever that is. 14 is the BGA dog bone. So it's essentially the same edit we just did, except going a little further, and we actually have to hit the BGA pad that has no V on it. So that's going to be an adventure. But let's put this cap back on first. I gotta rotate this to get it a little happier. So that is C9 done on the iron, and one last cleanup and visual inspection and electrical check. All right. So that's done. Flip it over. 16 is still happy. All right, well, I think we're done for today. Thanks for watching, and we've got challenge 14 still on deck for sometime probably later in the week, and we'll see when I have the time to get to it, because it's probably going to take a while. See you all next time.